Hi and welcome to video 4 in this video series on Unit 4 Topic 1 General Mathematics, and this is the Financial Math unit or topic, and we're looking at simple and compound interest today and how they relate directly to arithmetic and geometric sequences from Unit 3. So you recall that the simple interest is equal to PIN and I is the common difference, because each time we go through a year we start with our principal and then we add the amount of yearly interest. And then we add it again, giving us 2 yearly interest. Then we get 3 yearly interest. So as a recurrence relation, AN plus 1 equals the previous year plus that interest amount. Also, as an nth term relation, TN plus 1 is equal to, let's just make it TN, the nth year is equal to P plus, and then it's NI. P plus NI will determine where we are at. Now we've got to be careful with how this syncs up, because we could have a N minus 1 is the standard form that we learn in sequence and series if we're starting at term 1, but if we're defining that the first term is term 0, then we just get N. So there's a slight little sync there. You've got to be careful in your context. Compound interest, on the other hand, is that A is equal to P times 1 plus I to the power of n. So if P is equal to A naught, the first term, then 1 plus I is the common ratio. After 0 years, we have P dollars. After 1 year, we have P times that common ratio. That's our original amount, the 1, which is 100%, plus the interest. And then we get the original amount plus the interest squared, because we've applied interest twice. And then we've applied interest 3 times. And eventually, AN plus 1 is equal to AN times 1 plus I. That's the common ratio R. This is the new term, and this is the original term. So we're going from N to O by multiplying by a common ratio R. And alternatively here as well, TN is equal to A, our first term, times R to the power of n. Again, I'm kind of defining the first term as T naught, as I've done up there, which is why I do not have an n minus 1. So there's our relationship between sequence and series, compound and simple interest. Let's have a quick look at an example. Bobby's offered 2 investments for his $1,800 in savings. Simple interest at 3.7% per annum, or compound interest at 3.4% per annum. Compare these 2 options for a 5-year investment and advise Bobby on his best option. So in this case, he's offered 2 investments. Let's look at each of them in turn. First of all, the simple interest investment, we can work out the interest earned, and his interest will be equal to his principal times by the interest rate times by n. This is a 5-year investment, so we're probably still better just using the formula times by 3.7 over 100 times by n, which is 5, and I'll do that calculation now, and I get $333. And of course, that's over 5 years. He started with that $1,800, so the amount he has is the principal plus the interest, and that's equal to $1,800 plus 333, which is $2,133. And option 2, compounding, the amount he'll get when he's compounding will be AP 1 plus I to the power of n. Now P, in this case, is our principal, which is 1,800. And 1 plus I in this case is 3.4 over 100 to the power of 5. And I'll just quickly work that out. And that's equal to 2127.53. And so option 1 is slightly bigger than option 2. But option 2 will definitely be catching up to option 1. So you'll see that link up happen. All the best.